Module 4, Lesson 4 deals with zero and negative exponents. The content objective says that students will simplify expressions that have zero and negative exponents. And I'm telling you guys, it's a really easy thing to do. Might be a little confusing on the negative side, but I know you're going to get there. Suggested pacing claims this is going to be a 2-day lesson, so we better get started because we apparently have a lot to cover, including 21 resources for this one. Do you know why no two snowflakes are exactly alike? Snowflakes are made up of water molecules which grow at varying patterns and rates. Some snowflakes are very small in size, the smallest being no larger in diameter than a human hair. Wow, okay. We don't deal with a lot of snowflakes down here in the deep south. About once every 10 or 20 years, I think we actually get some real snow. I think it's closer to 20 years we get some real snow down here. Suppose a snowflake has a diameter of 10 to the negative 2 centimeters. The diameter is a measurement of length, which can length ever be a negative number? No, it can't. So we're not actually going to give us a negative value by having a negative 2. What that negative 2 is going to do is it means we're dealing with a really small number, and we're going to learn more about that as we go through this lesson. So our inquiry question wants to know, what does it mean when a number has an exponent of 0? And we're going to explore that just a little bit and see how all that works. Consider the expression 2 cubed divided by 2 cubed. What do you notice about the expression? Well, I notice that the top and the bottom are identical, and whenever you divide two identical numbers, what's your answer always going to be? It's always going to be 1, because 2 divided by 2 is 1, 3 divided by 3 is 1, 4 divided by 4 is 1. So in my mind, I'm sitting here thinking 2 cubed divided by 2 cubed, well, that's going to be 1, 2. Now we're going to simplify the expression using the quotient of powers property, which means we're going to subtract the exponents. And when we do that, we're going to take and find that we have a pretty big issue with our exponent. So right here on the table, you can see we got 2 cubed minus 3, which gave us 0. And where you had 2 to the 0th power, laundry just finished, where you have 2 to the 0th power, then you've got over here the final answer of 1, because 2 cubed is equal to 8, 2 cubed is equal to 8, 8 divided by 8, well, that's 1. Well, right here, if I had 3 to the 5th divided by 3 to the 5th, that would mean 5 minus 5 there, which would give me the same 0 for an exponent, and then 3 to the 5th, that's 125. I'm sorry, it's not either, so it's going to be 27. 3 times 3 is 9, times 3 is 27. Oh, nope, higher than that. Times 3 is going to be 60, 81. Times 3 is going to be 243, I think. Let me check my math on that. So checking my math, I'm going to do 3 x to the y 5 is equal to, hey, 243. How about that? Just like I came up with in my head. Impressive what you can do when you exercise that brain. And of course, that is going to equal to 1 as well. Now when we keep exploring here, that's going to become 4 minus 4, which is going to be equal to 0. And 4 to the 4th, well, 4 times 4 is 16. 16 times 4 is going to be 64, and then 64 times 4, that's going to end up being 240 plus 16 is going to be 250. Oops, typed that in the wrong spot. 256. Nope, that's not where I wanted it to go. 256 over 256, and when you divide those, you're going to get 1. And then here, that one's going to be pretty easy. 5 squared divided by 5 squared is 5 squared minus 2, which means you got 5 to the 0th power again. And over here, 5 squared is 25 divided by 25, which is still equal to 1. So it doesn't matter what numbers we put in there. Every single time when you ended up with a exponent raised to the 0th power, your answer is always going to be 1. And that will happen for any number or any variable except for 0. 0 to the 0th power, that's still going to be 0. Any other number you ever have, if you raise it to the 0th power, your answer will always be a positive 1. And that leads us straight into the 0 exponent rule, which I have a feeling they're going to give us some cards here to actually define. That will be a vocab word on your upcoming vocab quiz. Any non-zero number to the 0th power is equivalent to 1. That's going to be your 0 exponent rule. If we were to take a look at it using algebra, that means x to the 0 is equal to 1, where, like I said, x cannot be equal to 0. And if you wanted to see it in numbers, 5 to the 0th power is always going to equal to 1. I mean, this is one of the easiest rules in math. Not very hard at all. You just got to take a minute to think about what it's saying. Why is any non-zero number in the 0th power equal to 1? And we're going to study the pattern. Well, I think we've actually already studied that pattern, but let's go ahead and study it some more. The pattern in the table shows you that as you decrease the exponent by 1, the value of the power divided by n each time, by extending the pattern, n divided by n is equal to 1, so n is equal to, yeah, that makes a whole lot of sense. So let us take and actually make our screen a little smaller, and we're going to start going through this. First, you've got n to the 5th, which would be the same thing as saying n times n times n times n times n. And from there, they're going to take and subtract 1 from it, making n to the 4th, which gives you the 4 n's. And then you can subtract 1 from it, making n to the 3rd, which is going to give you 3 n's. I see where they're going here now. This is some good stuff. And then they're going to subtract another 1 from that. That's going to give them n squared, which is 2 n's. Do you see where it's going yet? If they subtract 1 more from it, they get n to the 1st, which is 1n. Well, if you subtracted 1 more from n to the 1st, what do you get? You get n to the 0th. And since you have all these numbers here, you're just going down, 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 down. That's the reason you end up having 1 here, because it's no longer going to be an n value. It's going to be the value of 1, because that 1 is going to be the least prime factorization, not even prime or composite. So which one of these expressions are going to be equivalent to 1? Well, 2 to the 0th. I said 2 to the 0th is going to be 1. 1 to the 0th is going to be 1. And 1/2 to the 0th is going to be 1. That is going to be it. Check our answers. Ooh, what did I do? Oh, dang it. 1 to the 1. That's 1 times 1 is 1. And that's going to equal to 1 as well. Now we have all of our right answers. So let's take a look at a textbook example of how to solve a problem. Simplify 12 to the 0th power. Any non-zero number to the power of 0 is equal to 1. Type a 1 in there. So 12 to the 0th power is equal to 1. I'm telling you guys, this isn't a hard concept here. Keep going. And now it's going to be your turn, and I'm thinking here that, you know, this is so easy, I'm not going to make you pause the video. X to the 0th power, where x is not equal to 0. What is the answer going to be? Anything raised to the 0th power, except for 0, has got to be 1. Check your answer. I'm telling you, I don't know how y'all are going to handle this hard homework tonight. And now that I've shown you how easy it is to raise or find the answer to an exponent of 0, we're going to start exploring negative exponents. Is going to be the next thing here. A cake is cut into 16 pieces. You serve half of the pieces to your friends. Each day you continue to serve half of the remaining pieces until 1 piece of cake is left. Now we're going to complete the table to show how many pieces of cake remain each day, both in exponential form and in standard form. So you can see that you had 16 pieces, which is 2 to the 4th. So the next day, which gave you a total of 16, the next day you had 8 pieces, which was 2 to the 3rd. The next day you have 2 squared, which is going to be 4 pieces of cake left. Then you have 2 to the 1st, which is going to be 2 pieces of cake left. And then you have 2 to the 0th. Well, that means that you have 1 piece of cake left. Now from here, you notice each time we go, or each time we drop our exponent over here, what's happening to our numbers over here? They're getting smaller. So when we go into a negative exponent, these numbers, they can only get smaller yet. Now we have a cool talk about it here. It says, notice that 2 to the 0th is going to be your last expression that you see right here, and that is equal to 1 piece of cake. And it says, well, predict what would happen if we took 2 to the 0th and divided by 2, because each one of these we divided the exponent by 2, which was 16 divided by 2, ended up giving us 8. 8 divided by 2 gave us 4. 4 divided by 2 gave us 2, and 2 divided by 2 gave us 1. Now it wants to know what happens if you take 2 to the 0th and divide it by 2. So let's take and press our button here, and you can see that when you do that, you ended up with half a piece of cake left. So because half of 1 is going to be 1/2. Makes sense? Then if you kept going through there, each time you took and divided by 2, the next time how much cake would you have left? Well, what's half a piece of cake divided by 2? That means you only have 1/4 of a piece of cake left, which is a very disappointing amount of cake. So let's take and do divide by 2 again, and we're going to notice what happens as we continue to go through this. As we talked about here, we had 1/2 a piece of cake, and if I divide by 2 again, I'm going to go from 1/2 a piece of cake to 1/4 of a piece of cake. So 2 to the negative 2 gave me 1/4. 2 to the negative 3, well, that's going to give me 1/8, because 1/8 is going to be 1/2 of 1/4. And each time we take and divide by 2, our negative exponent value gets to have a larger absolute value, or more negative number, and then from there, our size of our actual cake, well, it gets down to something that's nothing more than a crumb before very long. So let's examine the graph bars in the sketch and estimate the values of power 2 with negative exponents, yada yada. So, hey, we already did that. I'm not sure what we're doing. I think we already talked about this. So, yeah, we already did that talk about it. So it's time to move on to the next slide, which says, continue the table and determine the values of the negative powers of 2. Recall that when you move through the table, you're dividing by 2 each time. On day 6, has been completed for you. So you see day 6 where we had a 2 to the negative 1. That was 1 divided by 2 was 1/2. So 2 to the negative 2, half of 1/2. Well, that is going to end up being a 1/4. Next we have 2 to the negative 3. Well, that one is going to end up being 1/4 divided in half. That will be a 1/8. And then 2 to the negative 4. Well, that's going to end up being half of 1/8. That will be a, whoops, need to get my fraction bar going here, 1/16. From there, we're going to hit check, and all of those answers are good. And you can see that the more negative our exponent gets, the smaller our value is actually going to be. Okay, we have done enough playing around with this. It is time to actually learn how to work with negative exponents. First, a negative exponent is a result of repeated division. That's going to be a vocabulary term you're going to have. And you can use a negative exponent to represent very small numbers. As we showed you, every time the higher the absolute value of your negative number is, the smaller number it actually represents. Every time you divide by 10, the exponent decreases by 1, and the pattern table shows 10 to the negative 2 can be defined as 10 over 100, because that would be 10 divided by 10 times 10, which is going to be 10 to 100, or excuse me, 1 over 100, or 1 over 10 squared. And now we're going to take and move through some steps here to figure out how this works. So 10 cubed, that's going to be 10 times 10 times 10, also known as 1,000. 10 squared, that's going to be 10 times 10, which is 100. 10 to the first, that's going to be just 10. 10 to the 0th, we've established is 1. And now we get to start taking and going the other direction. 10 divided by 10, or excuse me, 10 to the negative first, that's going to end up being 1 over 10, because notice on the right it says each time we're taking and dividing by 10. So now we're going to take and say 10 to the negative 2. Well, that's going to be divided by another 10. So now you have 1 over 100. 10 to the negative 3. We're dividing by 10 again. That's going to be 1 over 1,000. And I'm going to show you real quick what that actually looks like, 10 to the negative 3, because I think they're kind of jumping ahead of you here on some of this. So 10 to the negative 3, that would be written as 1 over 10 times 10 times 10, and that is where they're getting their 1 over 1,000 answer that they're working with. Now this looks like a really good place for us to stop part 1, come back, and we will do part 2 of 0 and negative exponents.